Bruce Momjian. I normally speak about Postgres, but today I'm going to be speaking about security. I'll explain in a minute why. I work for Enterprise DB, been working there for 16 years. And some of the research that I've done here obviously has been on their dime, so it's kind of fun. I'll explain that in a minute too. If you would like these slides, they are right here. You can download them. There are 58 presentations there and 98 videos of those presentations, including 640 blog entries, mostly about Postgres. But today we're going to be talking about security. So why are we talking about security? Why, as a Postgres core team member, am I talking to you about security? About 6 years ago, let me back up. I work on the CTO team at the company, and my primary job is to work in the community to keep it healthy and so forth. And one of the things that I realized, having done IT for so many years, is that when I was in security discussions, either with customers or when we were talking about it in regards to the database, I kind of understood the security concepts, and I could speak intelligently about the various options, but I realized that I did not have a full understanding of security. And fortunately, because of the type of role that I have, I went to my boss and I said, I'd love to do some research because nobody in the community really has a deep knowledge of security, particularly cryptography. And he said, fine, yeah, go do it. So I bought a bunch of books and I read them and I watched a lot of videos, and and I guess 9 months later I had 300 slides. You're going to look at 99 of them today, but there are another 200 also on that website. So the first one talks about really the foundations of cryptography, the mathematics behind it, elliptic curves, hashes, private keys, primes, and so forth. The second one primarily talks about SSL, or in more modern parlance, TLS. How TLS works, how you can set up certificates, how you can basically configure TLS, how it works, how it does the handshake, and so forth. The third one is about configuring hardware security devices. That covers things like the YubiKey, if you're familiar with that, and a couple other devices. And this one, which is the one that the organizers presented, is unusually the last one, but the most applicable perhaps, which talks about how to use cryptographic hardware to secure applications. Now, this might be a new topic to some of you, but effectively, cryptographic hardware is a specialized device that performs some cryptographic function. And normally, the value of that cryptographic device is its ability to be detached from a client terminal, from a server, and when it's detached, it takes its security capabilities with it. So you can imagine somebody steals the server, somebody steals a machine. If the cryptographic device is not attached, they can't do a whole lot with it if the system is properly configured. And that's what I'm going to be talking about today. Okay, so I'm not going to be talking about the mathematics of it. I'm not going to be really talking about TLS or how to configure it. Yes, I have those slides. They are on that website. I believe there are videos of all these as well. So if you want to really just make sure you're sitting down for that, because it's a difficult. I actually go back to those once in a while when I forget a small detail, maybe of how TLS works or how the secrets exchange. I'll be like, oh yeah, it's Diffie-Hellman, and oh yeah. You know, we have to create the certificates this way, and the private key goes here, and so forth. So, any questions before I start? Okay. Yeah, we're glad to answer questions as we go. Okay. So let's take a look. So we're going to basically talk about how we connect cryptographic hardware and these these application types. So OpenSSH, which is an SSH client, OpenPGP, which is used for encryption as well as email, and that type of thing, if you're familiar with that. We're going to talk about PIV devices, which you may not have heard of before, but I've become somewhat adept at those. 5, we're going to talk about my favorite use, Postgres, all right? And then in 6, we're going to talk a little bit about database encryption scope and a little more database specific stuff, and then finally private key storage options. Okay. Okay. So let's talk about OpenSSH. Now, as you know, OpenSSH is, hopefully you would know, when you type SSH at a Linux terminal, you're getting OpenSSH. There's really two. Just be aware there's two open things, and I've always gotten this confused. OpenSSH is the shell command, right? OpenSSL is the TLS library, okay? So just if you hear OpenSS and you think, oh, that's, that last letter is pretty important. Yeah, I know. H and L are pretty close in the alphabet, so they look kind of the same, and they got the big, but they are really performing a different service. So this is OpenSSH, okay? And what I have done here is to create a host that effectively does not allow passwords. So it requires a certificate to connect to SSH. That's the way I do all of my SSH, frankly. I do recommend it for most use cases, and there's two main reasons for that. One, it's fairly hard to steal the private key of a SSH pair because the key is never passed across the network in the same way that a password is. Okay? And then secondly, the key is so complex that no matter how many times somebody guesses, they're never going to be able to construct in any reasonable amount of time, centuries, right? Construct a version, a packet that actually matches. Okay? So again, two reasons. One, hard to steal a private key because, of course, it doesn't get passed. It gets mixed with other things. And then secondly, it's very hard to brute force it. That's the term we use. Okay? So again, if you are still using passwords, whether it's with Postgres or with SSH, you might want to be moving into something like an SSH, a certificate case. Any questions about that? Because that's kind of a fundamental thing, at least for me. And I learned, again, I used to talk about it and I sort of knew what I was saying, but I didn't really. Now I can really speak in the right terms. I can talk about the private key versus certificate. For example, certificates are publicly available. I can see public certificates for websites all day if I want to. It's the private key that's actually the secret that you have to prove you own the certificate. That's really what you're doing when you're logging in. So again, I'm not talking. I have and this is somewhat disappointing. The configuration of this actually is in the previous slide deck, right? So I submitted all 4 slide decks. We've chosen this one. I think it's the right one because I think it's going to be most applicable. But again, if you want to know how to configure SSH with hardware security devices, look at the previous deck. It's called, instead of being called Cruising Cryptographic Hardware to Secure Applications, it's called Cryptographic Hardware Configuration, and it talks about how to configure all these things. Okay, so because I am using a YubiKey in this case, and you can see that right here. I don't work for YubiKey. I don't have any of their stock. It's just a cheap device that is fairly highly functional. It could be an RSA device. It could be any of these. Does anyone use any of these devices regularly? Yes? Okay. What manufacturers? That would be good to help to know. Gemalto. Oh yeah, that's an old, they've been around a long time. Yeah. They've been around long. Other people? Okay. YubiKey, other ones? Yeah. Nitro. Oh, is that also YubiKey? No. Nitro is a separate company. German. Oh, I have heard of them. Now that you're, yeah. Anyone else? Is that the big ones? Okay. Anyway, yeah, it's kind of interesting. I actually have one. I actually have one right here. If you're really, really super curious, you might laugh, but maybe I don't. Oh, I think I lost. Yeah, exactly. You totally got me. Yeah, I was carrying it in here forever, and I might have just stopped carrying it because I was like, oh, why am I carrying this thing around? No, I guess I don't have it. YubiKey, yeah, it comes in different formats, so you can get it in. Yeah, exactly. You can get it in a little size that's effectively the size of a USB ending, right? Just that little square, the USB part that you go is literally that big. And then they have more of a like a memory stick size that you can put in. They have a USB-C version that you can stick in your phone. So there's different formats. Again, Gamalto's good, Nitro's good. They're all really good stuff. But here I'm using YubiKey. So basically, what I have to do here is I have to use a tool. I'm using a tool to show you the YubiKey. It's called PKCS15 tool. Again, we covered that in the previous slide deck. But it's basically reading the SSH key out and it's dumping it into a file. Now, remember, this is the public key, not the private key. We can't. That's actually the hugest advantage to SSH these devices. You cannot get the private key out, right? People sometimes ask me, well, why don't I just put the private key on a USB stick and use that? And you can, but keep in mind that when that USB stick is inserted, that private key is readable by the operating system. One of the cool things about these cryptographic devices, and I think the most valuable, is that the key literally cannot come off of the device. If you want a backup of that key, you basically create the key off of the outside of the device, make a backup, and then store the public and private key in the device. I actually have an example of that in my previous slide deck. Okay. So basically, it's asking for a PIN. These all require some kind of PIN, so you have to type it in, or you can manually do it if you want. And that actually is my key, my RSSH, my RSA key right there. That's the public part. Now there's some dots here. It's much longer, but you get the idea. And then what I can actually do is I can put the key into my openssh authorized keys file. If you're familiar, there's a bunch of ways of seeing the public key. One way is that one long string. It starts with SSH RSA and then a big string. You just concatenate it onto the end. And that's actually what I'm doing right here, concatenating, right? And then what's really cool is I can then do an SSH, okay, and I specify the openssh library, and I can actually connect without a password. Because what I've done is I've extracted the public. Remember, I said you can't pull the private key off of the YubiKey, but you can pull the public key. So I pulled the public key off. I put it in my authorized keys, and then I can actually SSH into my system with no password. But what is happening here is because I've specified the openssh library, it's going to reach into the YubiKey. It's going to pass something in, get it signed or encrypted by the private key to prove I am who I am, send it to the server, and then I've actually logged in, and it says I've logged in, and now I'm a new user. Okay, so that's an example. I just wanted to give you the flow of what this is going to look like. Again, there's a lot of presentations before this to get here. But the idea is, and you may not need to know the other presentations. The point is that what I'm doing is I'm using the hardware device to do a login without requiring a password at all. Okay. When I mean, it's very similar on my phone. Now I don't have a YubiKey on my phone, but it's a similar issue. If I start an SSH client here, there's a private key on my phone, and that's how I'm logging in. I'm not logging in with any kind of password. Okay. Another thing you can do is to effectively, instead of basically, you can basically add the PCS11 provider, so you do not need to use the -I. Do you remember I used the capital I? So again, if you don't want to use that for every SSH connection, there is a file called SSH config in your home directory. And if you add the lines I'm specifying here in the middle, then you can see at the bottom I didn't need the I, because it knows that there's a PKCS11 provider called openssh there. Okay, so that's kind of a way of avoiding that. Now I'm basically saying I'm always going to be able to use that. Okay, and again, if you're curious about more details, right here at the bottom we have a URL that might help you. Again, you might want to download these slides and just click on the URL and it'll take you right to that. You know, you can just spend hours in this thing just clicking on links and reading details. But again, if you're curious how I got there and what things, and again, this slide deck's also online, so it's easier just download it and click as much as you want. Okay. Another way to do this, if you're, as I said, you mentioned before that each time it's asking for a PIN. You see this asking for a PIN here at the bottom. So there is something called SSH agent. SSH agent is part of the standard tools that you typically get with SSH. And what it allows you to do is to basically cache the PIN for a specified amount of time. So then repeated uses of SSH is not going to require you to keep typing the PIN in. Effectively what we do here is we're starting SSH agent right here. And then we're basically using the passphrase. And then if I do that, you can see the next one, it doesn't require it. Okay, so it kind of like, it remembered that I needed it. And again, we have 2 URLs here at the bottom for details about that, how I got here. There's another way of doing this. I actually create a script for controlling SSH agent because I wanted to auto start. Again, I'm not going to go through the script. There's a lot of slides here that I'm not going to go through, but feel free to use the script, you know, copy paste from the PDF. You should have no trouble doing that. And basically all it does is it basically starts SSH agent when you log in and then it keeps it running, basically. Okay. And again, there's other tools out there that do something similar. Okay. Here's how you install SSH agent D, and then you can basically run it. And there's a bunch of other scripts that do similar things at that URL right there. Okay. Here's how you would start it in your login, and then you can see that effectively it works fine. So here we start the agent, and it basically is requiring it the first time, and then after that it doesn't require it. Okay, any questions about openssh? I was just trying to give you the framework of how that would be useful. And again, the big use of this is if you take your hardware token out of that computer, nobody can log in from that computer, right? That's really the value of these devices. Okay. Second one, OpenPGP. This used to be, I don't know, I used to see a lot of this back in the 90s and early 2000s. I don't see this as much. Maybe it's more standard. Maybe I'm less geeky. I don't know. But it's basically a library that allows you to do a whole bunch of security-related things. I think Phil Zimmerman is the author of this, and he's been around forever. Also, if you've heard of OpenGPG, which is kind of the opposite of PGP and GPG, it's the same thing. It does file encryption. It does signing using your key. It also does OpenSSH as well as PAM. You can even use it for git commit signing. I actually do use a YubiKey for git commit signing, but no, actually, I'm sorry. I use it for git pulling from an authorized host. I don't use it for signing. So eventually we may get there, but right now that's what I use it for. You can even use it for Postgres encryption, and again, there's a pretty good PDF there. Okay. So again, OpenPGP or PGP or GPG contained a single active subkey used for signing. So again, it's designed around email. But now it actually has become more like a PIV device. How many people know what a PIV device is here? Okay, we got one. So I'm just going to give you the background, and I'm going to show you a PIV device here, and also there's a huge amount of PIV in my previous talk. A PIV device is basically a credit card-like device that's used typically by companies and absolutely by the U.S. government. And it's very similar to a credit card that has a chip on it. You're familiar with the chips. You know, you have a credit card and it's got the chip on it at the top, right? Well, that chip, I know we've gotten them in the past couple of years, but that chip actually can be a hardware device, hardware encryption device. And that's exactly what a PIV device is. And it actually has 4 different roles. One is signing, one is encryption, one is authentication, and then there's a 4th one, which is kind of weird. But OpenPGP actually has those slots now, so you can have different keys for different purposes. Instead of having, because imagine in key rotation, you might want to rotate your authentication key every year, but you may never want to rotate your signing key, for example, because then your sign you couldn't validate the signatures anymore. So again, you now have the idea of rotating. Again, expiration and revocation are important, and it's very similar to how TLS works. And again, there's a nice Debian URL there about subkeys and how they work. So how do we install this? I'm going to install GNU PG2, and that it's not Postgres PG, it's GNU PG, right? It's GPG. I'm also going to install something called SC Daemon, which is called a smart card daemon, which is required for this. And if I now look, this is kind of like blow your mind, but if I now run GPG2, I actually can see inside of my card, my PIV card, okay? And you can see the version, you can see it's a YubiKey. I can set my name, my sex, my language, my URL of my public key. That's a nice thing, okay? And even there at the bottom, you can see the different keys that I have. The signature key, the encryption key, and the authentication key, okay? In this case, they're empty, but we can actually fill them out. So I'm not going to go through that, but you get the idea. There also is a GPGD agent that I wrote. Again, feel free to use it if you're familiar with it. Make sure you check it out, test it. There's no warranty, but it was just something I found useful to get it to start and to get it to manage that daemon, which is always running, because by definition it was kind of hard for me. Okay. So now if I run the GPG agent D, I can actually reset the GPG card, and that's actually using that URL there at the bottom. This is literally what you have to do to reset the card. And then I can configure the card via GPG. I effectively make a directory called YubiKey, and I delete the key in there. And then I generate a random pin for the key, and I then echo the pin into a file called openpgp.pin, and then I can actually run pgp change the pin, and it automatically will kind of set it for me. Okay. Now, if I want to go and I want to set my various pins, I can loop through. Set what's called a puck, which is there's a pin and a puck. The pin is what you use when you're just running it, and the puck is basically an administrative key that you use when you reset it. So I'm going to set that as well, and then we also have an admin that we'll set at the same time. So we have a bunch of random numbers. And there's an admin pin that we're gonna set as well. Okay. This is a little better visual, I think, of what's going on with the key creation process. Again, when you put the crypto hardware in, it's empty, right? So you have to generate the keys and get them onto the device before you can use them, right? So effectively what we have here is there's 2 parts of the key. Again, there's a public part and a secret part, private part, if you want to call it that. We have a master key, and we have a signing key, an encryption key, and authentication key. The YubiKey 4 has only 3 of those, which works just fine. So we set the master key, then we set the sub keys, and then we effectively copy the private key to a USB device. Because if I don't do that, I don't have a backup. Because remember, if you do it on the card, you can't get the private part back out. So I recommended generating it on the computer, maybe on a USB device, and then copying it over to the YubiKey and then removing the USB device and storing that in a safe somewhere, so you have a backup. Okay, and that's kind of what I'm doing here. So I'm going to do a GPG do key gen. So it's actually going to generate the key that I want for the particular slot that I'm interested in. Okay, and that's actually what I'm doing here. Again, another URL. I can set my name, my email address. I can put a comment in there. So it's kind of like interactive. You can kind of go through it. Then I can edit the key if I want. Now you can see the two keys right here that are now in the YubiKey in my case. The E stands for encryption. So that's my encryption key right there. Okay. Then I can add another key. Here I'm going to add an RSA key, and I'm going to say sign encrypt. So I'm going to pick E for encrypt capability, and then I'm going to do sign. And I'm going to run through it, and basically it's going to run through and going to create my keys for me. So these are the codes that GPG. The A is authenticate, C certificate creation, E encrypt, and S sign. And then your public, your secret keys, your sub keys, and your public keys is the way it displays it to you. Because when you look at the key itself, you can see there on the right, left, we have pub and sub. And then at the bottom, we have SEC and SBB, SSB. And then on the right, you can see the sign for S and the E for encrypt and the SC for the other. Okay. So again, it's pretty complicated. That's the way PIV devices work. And GPG allows you to access the YubiKey as a PIV device. If you want to do authentication, you can basically do that. You can see that you can effectively create those keys. Authentication key, and then we run through it, and now you see there is actually an authentication key stored here, right up here at the top, and then we're going to go through the same thing. You can now see authentication key is filled out, right? And now we're going to back up the keys, so I'm going to copy them over to a USB device so that I have them, right? And I'm going to pull it out and put it in a bank somewhere or in a safe. And then you can actually see that we have our keys all kind of ready to use. Okay. You can delete keys. This is how we're deleting them. Delete secret keys. And we can even import the secret keys in. And again, we have the wiki makes it a lot easier to use. Okay. We can move the secret key to the card. So again, we generated them separately, and now we're going to key to card is the command. So it basically takes the key that's in the file system and puts it on the card. So I'm going to put it in 2, which is the encryption key slot. And now I have, you can see an encryption key defined for in this card. Okay. And I can toggle between different keys, key 0, and it shows me key 0. If I go to see key 2, it shows me key 2. Notice how the star kind of moves around, that little star there kind of moves around for you. Okay. Key to card, again, this copies a file, a private and public key from your file system into your card. Here I'm going to do the signature key, and now the signature key has been loaded, as you can see. And I'm going to do the final, and now you can see all 3 slots are full. Okay. So all 3 slots now have keys in them. I remember I said there's 3 different slots in a YubiKey that you can use, and that's exactly what's going on here. Okay, and yeah, it's this like little syntax stuff of how it displays. It's kind of cool. Okay, any questions of configuring? Yes, sir.
I think key to card moves, or it copies, but then it deletes, right?
Yeah, it might. I don't remember. It might delete at the same time. I know I have to back it up first. Yeah. So as I backed it up first, and then, yeah, a key to card kind of wants it out of the file system. Now, because it's a little tricky, because for me, I would not normally store it on the file system. I would store it, I would actually do all my work on a USB device instead of doing it in the file system, because the file system gets flushed to disk. Even if I delete the file, it's kind of still there potentially. So I would do it everything on a USB key. But if you do that, then make sure you don't copy it to the YubiKey and have only one copy, because then it's gone, right? So I would almost like create a separate directory and just copy them all in there, and then do key to card while you're in that directory, and then just flush out the directory, right? So just a little, I wish this was simpler. That's what kind of got me. Like, there's a lot going on here that you have to understand to really make use of this stuff. It's not a plug and play in any sense of the word, at least to me, unless I'm missing something. Okay, yes, sir.
So what happens to your public key on the device? How do you, I guess my question is, if you want to change your private key, delete it off the device, how do you get it back to, you want to create another private key? Do you have to remove the public key, the initial public key off of the device? How do you start from scratch?
Sure. So the question is, how would you recycle or change the keys at some point, right? So the public key you can pull off the device at any time because it's public, right? In fact, the earlier slides showed you an example of me pulling the public key off, right? Of the YubiKey when we were doing it was OpenSSL. Remember, I just yanked it right off the device, no problem. That's the private key you can't get at, right? So effectively, you can't. The only thing you can do is to overwrite the private key on the device. Okay, so it gets a little tricky because if you're using it for encryption, for example, okay, and you're encrypting stuff, and then all of a sudden you decide, I'm going to change my encryption key, right? Well, we only store one encryption key on the YubiKey and all the PIV devices, not a YubiKey specific thing. So, what if you have something and you're encrypted and you just lost the private key, right? So what you almost have to do if you want to rotate keys like that is you almost have to decrypt all your data, right? Change your private key and then re-encrypt all your data back with the new key. And that's somewhat disappointing. Maybe you just buy a second YubiKey and you keep the first one around, right? Or at least you're going to keep that backup in the bank around maybe forever. Like maybe you're just going to buy 10 USB sticks and you're going to put dates on them and they're just going to sit in the safety deposit box or the safe, right? Because you can never know you've gotten all of them when you come back. So you can't. It has slots. We got 3 slots here. Technically, you could use slot 1 and slot 2 and slot 3 for encryption if you forced it to. I don't recommend it, but you can. You wouldn't be able to sign anything, probably, and you wouldn't be able to authenticate using it, but you could potentially use those all for the same purpose. Then you could get 3 of them in there, but it still becomes like a mess, right? So I think that's a problem. I don't really know what to tell you except, yeah, I think the good news is that this stuff is so secure and so non-brute forceable that you're probably not going to be rotating your keys every month or maybe even every year. It may be a 5-year, 10-year thing that you're going to be rotating these things. Because remember, if you're holding the YubiKey and the copy is never left the safe, then nobody's been able to get that out of there. It's not like a USB stick, somebody making a copy and you don't know it, right? There's literally no way for even the manufacturer, I think, without using electron microscope to try and read the storage on it's just almost impossible. So that's, I think, a different scope of risk that we're used to. That's why we rotate passwords, because they get, who knows where they go, right? They get passed over the network, they get written down, these are not issues with a hardware token, and that's why I got kind of excited about them. Did that answer your question? Yes, sir.
What would be a good method to mass deploy this?
I'm sorry?
What would be a good method to mass deploy these YubiKey?
What would be a good method to mass deploy these keys? Well, the real trick would be to automate the config of these things, right? Sort of what I've done, and then you would just hand people a key. They wouldn't know you have a backup. They wouldn't know what slots are. They wouldn't know anything. It would basically be a pre-configured. I would never give an end user this. It's just like, don't even go there, right? I did it because I'm crazy, right? But a normal person you'd have, and the beauty of the thing is once they have it, if they don't lose it, and even if they do lose it, the person has to guess the PIN. I haven't even talked about this. You only get like 5 guesses at the PIN, and if you fail 5 times, the device is literally locked. You can't get in again, period, right? Now there's a administrative pin which will allow you to unlock it, but you can only try that one, I think, 10 times, and then that'll lock up. So you almost have to assume that if this thing's compromised, it's gone. Nobody can read it. You have a backup. You make a new key. The other one is just dead. And hopefully you have it. If you don't have it, I guess, I don't know. I guess maybe you make a new one. I don't know. But that's the interesting part. The physical thing is very important here. And if you configure it, yeah, it just runs. Once you configure it, they run normally. You just stick it in and you SSH and you're in. Like there's no, that's how Google does it. All these big, a lot of organizations, the Gemalto and Nitro, all these organizations are using it for mass deployment. Everything's pre-configured. All their SSH is configured. All their config files are configured on every laptop. And you just stick it in, you're in, pull it out, nobody's going in. Yes, sir. So the question is a YubiKey and a PIV device, or I mean, credit card and a PIV device the same? So yeah, you have a great point. So the traditional use of a PIV device is a credit card. It has the person's picture on it. It's government. Any government ID is going to be a PIV device. So it has a person's picture and a bunch of stats about them, and then a little chip. Okay, that is the way the government has basically implemented PIV from for a decade or two, right? What we see now in the past 7-8 years is that PIV device, they're disconnecting the card from the chip. And now, instead of having the traditional way is you have a PIV reader and you stick the card into the reader. You see them in movies, right? The guy puts a thing in, and that's how it works. It actually checks the authorization slot on the PIV, and it finds out who it is and validates their name. That's why you have a name slot in there, the whole thing, right? What we've seen with the YubiKey and the Nitro and so forth is now taking that credit card and shrinking it down. We don't need a credit card anymore. We don't need a reader anymore. We just need a USB slot, right? So there is a YubiKey PIV device that's literally the size of the chip itself that's on your credit card, okay? And then there's also some that are bigger, like more of a memory stick with a little stick on the end. There's one that sits in your cell phone in the USB-C slot. You just stick it in the slot, and then it functions as a PIV device. So you're starting to see more form factors. It's a little different, and the picture's not on it, but it's obviously more functional because now we have a direct USB interface to PIV devices that we didn't used to have before. We used to have a card. The card would have to go in the reader. The reader would have to be connected to the computer. And that's the way the government systems work. You have a terminal. You have a PIV reader. You stick it in. And that's how you authorize yourself on that device. Did that answer the question? Yeah. So the attributes that I showed, are they specific? Okay, so the attributes that I showed are, I believe, so you're asking about the attributes like SCC and stuff like that. So some of the stuff is standard, like this, all these fields, these are standard part of PIV cards right here. This is all standard PIV. All PIV cards have all these fields, I believe. The difference is that this appearance, this is all PGP. This is all very specific to PGP. And in fact, I even mentioned that it changes in another release and stuff. So this is how they're displaying. They have to map the left-hand side, the right-hand side. And that's how they're doing it. Yeah, sure. Other questions? Yep, sir. So why would you use YubiKey key generation? Because you don't have a backup? Is that what you're saying?
I'm asking, like, you're doing generation on an insecure device.
That's right. That's right. Right. That's correct. So why would you do it? So the question is, the reason I'm generating it separately is so I can make a copy and back it up, right? That's why I'm not doing it on the YubiKey. Why would you want to do it on the YubiKey? You may not care about a backup. You may basically say, if I lose this, then my authentication is no good, and I'm going to have to get a new authentication. Somebody's going to have to give me a new key. Nope, nothing wrong with that, right? I gave the longer one because if I'm doing encryption and I encrypt something, I want to be able to decrypt it later. But for authorization, if you lose the device, you just go to the administrator side, I need another YubiKey. They're like, okay, we'll invalidate the old one and we'll add the new one and we're done. Right? So again, depending on whether you need that backup would determine whether you do it on the YubiKey or not. Much easier to do it on the YubiKey, no question, right? Because you just issue a command and it'll fill in all those slots, no problem. Right? Good. Yes, sir.
Just want to point out, since we are at a Linux open source conference, UPG, open source, key generation algorithm on your UPG. I don't want to talk down UPG, but I'm just going to say you don't have the source code, you don't know how specific how it's generated. Capacity, UPG has a role in multiple elements of their. But you can't look at the source code.
Are there any hardware devices that have open source code for that guy? Yes. The Nitro is open. That's great. Good. I learned something today. All right. So the Nitro has its source code open. That's kind of cool. Yeah. Great point. Yes, sir.
What is the acronym for PIV?
PIV is
Personal identity.
verifier. Yeah. Yeah. Personal identity verifier, I think. Yeah. Yep. Other questions? Good questions, by the way. Yes, sir.
All the slides show 24/8-bit RSA key. Is there kind of a path forward to the PIV card support other algorithms? What's the future in the post-RSA world?
So the question is, yeah, so the question is what different encryption, public key encryption methods are possible with these devices. Basically, YubiKey supports a couple of them. I don't know what the Nitro supports or Gemalto, but effectively, these devices could support any public-private key specification. It can be anything. Right now, it's that, but there's nothing hardwired to the specification that indicates what it has to be. Okay, yes, sir. Ma'am, I'm sorry, sir. Does the YubiKey support elliptic curve public keys? I don't remember. I'm sorry, I don't remember. I don't think so. That's a great question, though. I wish I knew the answer. Other questions? Okay, all right. Let's actually run. Let me just show you the use of this key so you can kind of see it. So here I'm using the word test, and I'm piping it into GPG. I'm asking it to encrypt with Armor. I'm giving the recipient ID, and then I'm decrypting at the same time. So I'm actually going in, encrypting it, and then decrypting it. And you can see test goes in, and test comes out, right? If I want to sign something, I can use a clear sign, and you can see it comes out in the same way. Okay, so that's an example of using YubiKey to sign and unsign something. You can use OpenPGP with OpenSSH. So remember I showed you OpenSSH using it with like the standard traditional. You can have OpenSSH use OpenPGP. So here we have a normal SSH that's failing. I can do an SSH add with the public key of the YubiKey, of GPG. There's my setting, and then I can actually concatenate that on, and then all of a sudden SSH will use the OpenPGP key instead of the PIV key, depending on how we want to do it. Okay. This is a very complicated slide. I'm not going to go into it. It's basically the software stack for these public devices. And it is not pretty, right? You got OpenSC tool, PKCS11 tool, PKCS15, and then over on the right, you have the internals of the YubiKey. both the PIV part and the OpenGPG part. There's actually two parts inside a YubiKey. One's the PIV, which is what the gentleman asked for, and then there's another part which is OpenPGP, and then there's another part which is just for authentication. So, not fun. Okay. PIV versus OpenPGP. This is kind of just an informative slide. Which one should you use? PIV stores all user information on removable media. OpenPGP really was kind of designed for storing the keys in the file system. So you're kind of copying over. What's interesting is that a PIV has the public and private all on the separate device. So it's made to be removed and added. For PGP, it really kind of expects the public part to be in the file system. So it's not really thinking of you inserting and removing and coming in as a new user in the same way. So you may want to favor one over the other depending on what type of system you're using. Okay, and again, application support. Okay, let's talk a little bit about the Postgres side. And again, this is going to be super complicated, but if you were in my talk on Friday, where I talked about, actually, if you were in Jim Mulginski's talk on, anyone here in Jim Mulginski's talk on Friday morning? Right, we have two. He gave my talk. It's this slide. So he actually ended up using my slides for his talk. And here the concept is that to do Postgres, you have the encryption key removable like a PIV device, okay? And you're effectively encrypting and decrypting on the client before you send back and forth on the network, okay? You could also do that with symmetric keys, but it's not as secure. Here's an example of this. Basically, I'm creating a user key, and this is a whole bunch of PSQL, which I don't expect you to understand, but the idea is that we generate some random numbers, we put in a variable, we actually store that into RSA util, so we can kind of find out what's going on. We put that in another variable, and then we can actually, from the YubiKey, use either decrypt it, encrypt it by sending the keys across, or we can actually do the encryption on the client. So again, I'm not sure how you want to do it. This is a lot of stuff here. But the goal, like for example, this particular slide is showing that when you remove the YubiKey, nothing happens. You get an error, right? It's basically saying, I can't issue this query anymore because I don't have the key anymore because I removed it. That's what you want to prove, right? If you're going to test it, pull the thing out. Does it still work? It better not. is the goal, right? Here's a more sophisticated example, again, way beyond what we want to sort of cover here, but Postgres has encryption. There's some libraries we can use to encrypt stuff. There's even a PG get key that I used to allow you to send keys back and forth. I'm not going to go into this, but again, you can actually use the hardware security module on the server, on the database server. You plug it in, it operates. As soon as you pull it out, nobody can read the data anymore, right? That's what we want. Kind of cool. Questions? Yes, sir. So how do you handle cases where the key has to be, the device is moving around and you're not sure where to put it, or so you're moving between VM hosts. The only real good way of doing that is to make duplicate hardware keys and put them on each device, right? And again, if you're generating the key externally, you can do that because you just put a new key in and you go through the same process again. And now you have two keys that are identical and they'll function. But then obviously if you remove them, you want to remove both of them so that nobody can use the other one while you're, yeah. Good. Yes, ma'am. So in this case, this is basically a special utility I wrote called PG get key, which will pull the key off of an HSM or a YubiKey or something like that. So yeah, it's very specific to Postgres, so I didn't really want to cover it here. But again, you can set up keys for functions, and yeah, this gets just like super, super complicated. You can use it for transparent encryption if you want that feature. And again, I'm just running through. Here's a case where we actually have a trigger on a function, and we pull the key off of the YubiKey or the hardware security module, encrypt it, and then continue. So we can actually by looking at the bottom, every time somebody does an insert or an update, we automatically encrypt it with the key that we got, right? Again, this is very databasey, so we're not going to cover it, but if you want to go into this, feel free to do that. Okay, here's a transparent insert, right? I just inserted the word test, which is up here on the top line, and you can see when I do a select from the view, which decrypts it, I get the right data, but if I go to the raw data, you can see it's encrypted, right? Right, so this is me inserting test. This is me running through the trigger. This is me just looking at the raw data. And again, as soon as that key's out, the view won't work either, which is the whole goal of what we're doing here, right? Same thing with update, same thing with delete, right? And again, yeah, update. So some performance issues here of how fast it is. Indexing issues. Data key expiration. So the idea of having to rotate the key every so often, very difficult to do. Again, very databasey. I don't want to kind of go too much into this. But you can basically encrypt your data, or you can encrypt your keys, and this is some of the ways you can do encryption inside a database. This is not a database talk for this audience, but I just wanted to kind of, I'll just go through the slides. So again, it's like, where do you want to store? One of the primary reasons I got excited about this is, if you're doing encryption on database, where are you going to put the key, right? Are you going to put it unencrypted in the file system, which some people do? Are you going to encrypt it in the file system and then require a password to decrypt it? Or what we're doing here is encrypting it and requiring a PID device or a PIN to decrypt it. And I think that's the real final thing I wanted to get across. I'm not saying you have to do it, but I'm saying this is how people do it if they want that level of security, okay? And again, how do you want to store it? It's also called a CAC card, if you've ever heard of CAC. That's the more familiar term. And it's called a CAC card, but it's really common access card, so it's common access card, so you get the idea. It should be just a CAC. But again, you have a CAC option, you have a YubiKey option, you have a USB option, hardware security module option, or just external option. Again, we have a nice, very hefty URLs here at the bottom about these details. Okay. All right. So thanks very much. I'll take some questions. I know I'm a little bit over, but I don't want to lose that opportunity. Yes, sir.
For mass update, what is administrative to invalidate the key? How does that work? If somebody you had 100 keys and somebody lost a key, what actually is the invalidated process to invalidate the key?
So how would you invalidate a key that was lost? How do you invalidate a key?
Yeah, how do they do it? The mechanism behind it.
What's the process, right? So so how do you invalidate a key? You really have two options. You can either create a new key from your backup and don't invalidate it at all, right? With the assumption that even if it's stolen, nobody can read it because they can only get a couple tries at the pin. Right. Well, all right. So if you want to, so basically, if it's for authentication, then all you really are going to do is to just issue a new key and invalidate the old one, because it's just like a new password, right? So if it's for SSH logins, just remove the old line, you put a new line in, you're done, right? If you're encrypting data, then you're probably going to need to go to your backup, decrypt all the data using your backup, right? And then create a new key and re-encrypt it using the new key, and then that's your new key. Yeah. The interesting, for authentication, there's no lifetime to the authentication. You're authenticated today, and tomorrow you do it with someone else, right? With data storage, then you have a lifetime of that key now, and you have to expire that key by really removing its use and then making a new one.